Let's start talking about quadratic functions by thinking about the word quadratic. It comes from a Latin word, quadratus, which means square. What does the word square remind you of? That is one way to think of a square. A square is a polygon with 4 right angles and 4 congruent sides, but there's another thing that we can think of when we think of the word square, and that's a second power. So the function f of x equals x squared is a quadratic function. And sometimes we replace f of x with y, so y equals x squared is also a quadratic function. Let's look at the graph of y equals x squared, and we'll do it by just making a table of values. When x is 1, 1 squared is 1 times 1, so that's 1. When x is 2, 2 squared, that's 2 times 2, which is 4. And when x is 3, 3 squared is 3 times 3, which is 9. So now let's graph the points and see what we've got. Do you notice that the points do not lie on a straight line? Okay, so let's continue our graph, but let's go to the left of the points we already have. So let's go backwards from 1 and try x equals 0. 0 squared is 0. Negative 1 squared is negative 1 times negative 1, which is positive 1. Negative 2 squared is negative 2 times negative 2, which is positive 4. And negative 3 squared is negative 3 times negative 3, which is positive 9. So let's graph those points and see what we've got. That's a very distinctive shape. In fact, that shape is the shape we expect to see for any quadratic function. The graph of a quadratic function is called a parabola. This one is the graph of y equals x squared, which is considered the parent function for all quadratic functions. If the equation for the quadratic function is changed a little bit, the parabola might move from what we see here. It could move left or right or up or down or even flip upside down. It's those changes in the equation y equals x squared that will make those transformations of the parent function happen. In general, the equation of a parabola written in standard form is f of x equals ax squared plus bx plus c. A parabola's equation will always have a quadratic term. That's the term containing the x squared. It might have a linear term, that's a term containing an x, and it might have a constant term, that's just a term that's a number. Our parabola's equation, y equals x squared, had a value of 1 for a, 0 for b, and 0 for c. Now that we know the basics about parabolas, we can move on from here and talk about some of those transformations another time.